Hello, and welcome to part two of our walkthrough of the NCEA Level 2 electricity exam. Lightning is typically caused by a buildup of electrons in clouds being released to Earth. The bottom of the cloud is negatively charged, and the ground under the cloud becomes positively charged. We can see that in the diagram on the right. The cloud and the ground can be modeled by a pair of parallel plates. The voltage difference between a particular cloud and the ground is 4.65 times 10 to the power of 7 volts. The cloud is 1.82 kilometers above the ground. Calculate the electric field strength. So electric field strength, what you're looking for on your formula sheet is the E, but not the energy. So the formula we want here is E equals V over D. And you'll notice we have been given a voltage and we've been given a distance. Now, we are going to want to convert that distance into meters because distance always has to be in meters. So times that by 1,000, and that's 1,820 meters. So we will go E for electric field strength equals V, 4.65 times 10 to the power of 7, divided by D, 1,820. And that gives 2,554.9.45055, which I think we will just round to three significant figures, so 25,500 volts per meter. There we go. Nice achieved to get us started on question 2. Let's go on to part B. A weather balloon is released from the ground. The balloon has a charge of 4.20 microcoulombs. Micro means times 10 to negative 6, so that's 4.20 times 10 to negative 6 coulombs. You won't be given that on your formula sheet. That's just something you need to know, that micro means times 10 to negative 6. Calculate the size and direction of the electrostatic force exerted on the balloon when it's halfway between the cloud and the ground. All right, we're going to use this formula here, F equals EQ, because we know the charge, we want to know the force, and we know from the previous question what the electric field strength is. So in the exam, what they'd probably do is make that show that question, because we need that number somewhere else. If you see it show that question in the exam, it's a good hint you're going to need that number in one of the following questions. Okay, so for us, F equals E, so that was 25,500 times by the charge, 4.20 times 10 to the negative 6. And that gives an answer of 0.1071 newtons. But that's not quite the answer because we were asked for size and direction. Now the direction will be upwards. If you want to know why, let's take a look at this diagram again. So the ground is positively charged and the bottom of the clouds is negatively charged. So if we have a balloon, that's a balloon. Yeah, I better label that because it's not exactly clear. That's a balloon. And that is, we were told that's positively charged. So the force will be, you can either think of it as being repulsed by the positively charged ground or attracted to the negatively charged clouds above. So that's why the force is upwards. So this is a merit question. You get achieved if you calculate the force correctly, and merit if you also get the direction correct. So as far as merit goes, not too bad, that one. Let's go on to another merit question. How does the electrostatic force on an electron change as it travels from the cloud to the ground? Use physics principles to explain your answer. So this is not completely related to the previous question about the balloon, because we're now looking at an electron going from this cloud downwards, which it will do because electrons are negatively charged. It will go from a negatively charged cloud down to the positively charged ground. So how does the force change? Well, first of all, the field is uniform. So what that means, uniform means the same. So if the field is uniform, that means its strength and direction is the same all the way throughout it. And what that means is the force won't change. The force on that electron will be the same the whole way. So let's write that down and get that into words. So the field between the plates, or between the cloud and the ground, so cloud and ground, is uniform. So if you need to remember what uniform means, I always think of school uniforms. They're all the same. Well, within the same school. So uniform means the same. That's one way you can remember it. So if it's all the same, then that means that it has constant strength and direction. So no matter where you are within that field, the strength and the direction of that field are the same. So F equals E times Q. So the force on that electron is determined by the strength of the electric field and the size of the charge on the electron. Well, the size of the charge on the electron isn't going to change, and the electric field strength isn't changing, so therefore the force isn't changing either. So charge and field strength are constant, so not changing. So the force is constant. All right. As I said before, that is a merit question. If you get this first part, that is achieved. And for merit, you need both parts. Okay, on to part D, the last part of this question. An electron is discharged downwards from the base of the cloud with a speed of 1.80 times 10 to the power of 5 meters per second. It reaches a maximum speed of 4.30 times 10 to the power of 5 meters per second. Calculate the distance the electron traveled from the ground to have reached this speed. So we know some speeds. We know the maximum speed it reaches and the starting speed. So let's write out what we know. Vi equals 1.80 times 10 to the power of 5. Vf, final speed, that we're interested in, is 4.30 times 10 to the power of 5. We know it's an electron, so we know that the charge on the electron will still be negative 1.6 times 10 to the power of negative 19 coulombs. We also know that the electric field strength is 25,500 volts per meter. So this is all about energy. If the electron is accelerating, then it's gaining kinetic energy, because kinetic energy is half times mass times speed squared. So we need to know the mass. Now, we were given that right at the beginning. The mass of the electron is 9.11 times 10 to the power of negative 31 kilograms. So now that we know the speed, we can work out the kinetic energy at each of its different speeds. Now that changing kinetic energy results in a proportional change in potential energy. So as the kinetic energy increases, its potential energy must be decreasing. And from that, we can then work out the distance it has travelled. So let's start off by working out the kinetic energies. So we'll go EKI, so for initial kinetic energy. So half mv squared, so half times the mass times velocity squared. Need brackets there because I'm trying to square something that's also having times 10 to the power 5 on it. So put brackets around that. So that comes out at 1.47582 times 10 to the negative 20 joules. Very small number because the electron is so light. Okay, now for the final kinetic energy, very similar calculation. Just changing that speed to 4.30. And that increases the kinetic energy to 8.422195 times 10 to negative 20 joules. I've used the unrounded ones there because I don't want to have any rounding error in my answer. So we'll leave any rounding until the very end. Okay, so the change in kinetic energy is final kinetic energy minus initial. So now I'm going to take away those two answers, which gives 6.946375 times 10 to the negative 20 joules. So that's the change in kinetic energy. And that is equal to the change in potential energy. Because as one is lost, the other must be gained. So we're assuming conservation of energy here. Not just in mechanics, you need to know about conservation of energy. Right, now potential energy for a charge in an electric field is given by EQD. Bit confusing with capital E's because we've got capital E for energy, capital E for electric field strength. Remember that for energy, it will typically have the little K or P to distinguish that it's energy. If you don't see that, it's probably electric field strength. So we know E, we know Q, we don't know D, we know EP. So D is the only thing we don't know, which means we can find it. So if we rearrange this equation by dividing both sides by EQ, then that will get D by itself. And all the other stuff we know is on the other side together. So the change in EP is the change in EK, which is 6.946375 times 10 to the negative 20. Electric field strength is 25,500. And the charge on the electron is 1.6 or negative 1.6 times 10 to the power of negative 19. The negative is not important here. So that comes out at 1.70254 times 10 to the negative 5. If you used a negative answer if you used a negative for the charge on electron, this would just come out negative. Doesn't mean an awful lot. The distance is still, it would just be negative 1.7 instead of positive 1.7. We'll round that and we'll go 1.70 times 10 to the negative 5. Always write the unrounded first and then round it after to show the marker you did get the exact answer and you have just rounded it. So this is an excellence question. So for achieved, you have worked out one of these kinetic energies. For merit, you have got to this stage here. And then for excellence, you have calculated the distance. Okay, well, that's the end of that question, and that's the end of part 2. Thank you for watching.